This is 2002 AP Physics B question FRQ. Now these sections are covered in AP Physics 2. And the question states that two light bulbs, one rated 30 watts at 120 volt and another one rated 40 watts at 120 volts, are arranged in two different circuits. So for A part, the two bulbs are first connected in parallel to 120 volt source. Determine the resistance of the bulb rated 30 watt and the current in it when it is connected in this circuit, and then determine the resistance of the bulb that rated 40 watt and the current in it when it is connected in this circuit. So if I have 120 volt battery and I have the light bulb, so this sign represents the light bulb. Oh, you can do a resistor and another resistor or the light bulb connected in parallel, 120 volts, and then the first one I'm gonna call the 30 watt resistor or bulb, and the second one is 40 watt. And the watts are the power, so the power of both resistors are given when they are connected to the source of 120 volt, the way it is stated in the problem. So the power is equal to I times V, and because I times R is equal to V, the power formula can be rewritten as I squared R or V squared over R. Usually on AP exam, you will be only will be given this part of the formula, so you can replace V with I times R or I with V over R to get the rest of the formula. So they ask you to find the resistance, and because I know the voltage, they have the same voltage, so if I call this A point and this B point, voltage on AB is equal to 120 volts, and they share the same voltage. So if I want to calculate the resistance, I can use this formula. Power is equal to V squared over R, or the resistance is equal to V squared over the power. So for the 30 watt bulb, I have the resistance is equal to 120 squared over 30, and that is equal to 480 ohm. And then for the 40 watt bulb or resistor, I have the resistance. The resistance is equal to the voltage squared, which is 120 squared, divide the power, which is 40, and that will give me 360 ohm. So to calculate the current always flows from the positive plate of the battery to the negative plate of the battery. So the current is gonna go this way, and then it's gonna split to the current through 30 ohm resistor, 30 watt resistor, and 40 watt resistor. I'm gonna call this one I1 and this one I2. So to calculate the current I1, it is the voltage. I'm using Ohm's law. So it's the voltage over the resistance, and or I can use the power. Since I know the voltage and the power, I can also use the power formula, but I'll use this one already, the Ohm's law. So the voltage, which is 120, and the resistance of the first one, the 30 watt, the bulb, we have 480, which is 1/4, and that gives you 0.25 amps. And then the current on the second one, again, it's the voltage divided by the resistance, The voltage for both of them is the same 120 because they're connected to the same battery. And this one is 360, which is 1/3 or 0.33 amps. For the next section, for B, they say the bulbs are now connected in series with each other and the same 120 volt source. Determine the resistance of the bulb rated 30 watt and the current through that resistor, and then the same resistance of the 40 watt and the current through that resistor. Because the resistance depends on, so the resistance formula, if I look at the resistance formula, that would be the resistivity of the material, and then I have the length of the resistor over the area of that resistor. So you see that the resistivity depends on the structure of the resistor, or resistance depends on the structure of the resistor and the resistivity of the material. And since we already know the resistance of the material, and also you would use the beginning of the problem right here when they say 30 watt 120 volt and 40 watt 120 volt. That means if you connect it right to the bulb, to the battery, you would get these resistances for both of them, 480 and 360. So that doesn't change. That means the resistance of each bulb is still the same. So this one is still 480 ohm and this one is 360 ohm. But what does change is the current. So now in my circuit, I have the battery, and then I have one bulb connected after another bulb in series. So I have 120 volt battery, and then this bulb is the 30 watt bulb or 480 ohm, and this one is 40 watt bulb or 360 ohm. So the total resistance in the series connection is the sum of two of them. So that's 480 plus 360 in series connection. We just add them. So that will give me 840 ohm. And if I want to calculate the current which flows again from the positive plate of the battery to the negative plate of the battery, so if I want to calculate that current, the current is going to be the same through each one of them, because I'll have to look at the current as little aliens are running. So there are many different aliens running through the pipe, and then they have to pass through each room. Like bulb is like a room. They all have to pass, and the same ones will pass through each rooms, because there's no other way to get back to the battery but following the path that is provided in the series connection. So if I'm calculating the current, I have the voltage divided by the total resistance, which is 120 divided by 840. And the current in this case is going to be equal to 0.143 amps. For the next question, they ask you, in the spaces below, number the bulbs in each situation described in order of their brightness. 1 is the brightest and 4 is the dimmest. I'm going to calculate the power on each resistor when they're connected in parallel. Because they're connected in parallel, their power is already given. So this is how we found their currents. So the power in parallel connection for the 30 is going to be the 30 watts, and the power for the 40 is 40 watt. So that determines the brightness of them. So that means the 40 watt bulb is brighter than the 30 watt bulb. And then for the second circuit, we had the current floating through both of them, the same 0.143 amps. I can calculate the power on each by knowing their resistance and the voltage. but I know the resistance, so I'm going to use the resistance. The resistance of this one is 480 ohm, and the resistance of this one is 360 ohm. And the power is equal to I squared R. So I'm going to use this formula to calculate the power on each. So the power on 30 watt is going to be I squared, which is 0.143 squared times 480. And I get 9.8 watts, 9.8 watts. And the power on the second one, the 40 watt bulb connected in series, is again the current, which is 0.143 squared times 360, and I get 7.36 watts. So looks like the dimmest bulb is gonna be 40 watt bulb in series connection, and because its power is only 7.36 compared to the other ones, and the brightest one is going to be 40 watt bulb connected in parallel. So they say rate them by brightness. 1 means the brightest and 4 is the dimmest. So I know 40 watt in series connection is the dimmest, so this one is going to be number 4. And 40 watt in parallel connection is the brightest. And then the 30 watt in parallel connection, second brightest. And the 30 watt in parallel connection, in series connection. So 30 watt in series connection is the second lowest from the bottom. So that's going to be the third one. And for the last question, they ask you to calculate the total power dissipated by the two bulbs in each of the following cases, in parallel circuit and in series circuit. So I have both circuits redrawn. So this one is 30 watt resistor in series. This is 40 watt resistor in series. But in this connection, they would only produce 9.8 watts, the one that we calculated earlier, and 7.36 watts. So the total power drawn out of the battery in parallel connection is 70 watts, and the total power drawn out of the series connection is 17.16 watts. So you see that the parallel connection drains the battery faster than the series connection, and in series connection the bulbs are not as bright as they would be in parallel connection. So the currents through each would be higher when they are connected in parallel. So the current was 0.33 amps and 0.25 amps, and the current was lower for them when they were connected in series. And there's something else interesting to notice for the AP exam, not related to this question, but good to know. If you have resistors connected in parallel, their total resistance is smaller than the smallest. So the smallest of the two is 360. If I calculate the total resistance of both, I have to use the formula, which is 1 over R total is equal to 1 over R1 plus 1 over R2. And when I teach this subject to my students, I usually speak this problem differently, with this formula differently. I say 1 over, the result flip over. So we have 1 over, which is 480, resistance of the first one, plus 1 over resistance of the second one. And the common denominator in this case would be 1440. So to turn the first fraction into 1440 in the denominator, you have to multiply both of them by 3. And to turn the second one, you would multiply both of them by 4. So that gives you the numerator of 7. So the way we find the total resistance in parallel connection again is 1 over the result flip over. So I have to flip my result over. So the total resistance is going to be 1440 divided by 7. So the total resistance in this case is equal to 205.7 ohm. So you see the total resistance of the series parallel connection is smaller than the smallest, which is 260. And therefore the total current, the one that is leaving the battery, is going to be the sum of those two currents, which is 0.58 amps. So the higher current is drawn out of the battery. And in this case, in the second one, in series connection, the total current is drawn out of the battery is only 0.143 amps. And the total resistance in this case is larger than the largest, or it's the sum of the two. You have 480 plus 360. So the current in series connection is lower, and therefore the power is going to be lower as well, because the resistors or the bulbs are the same. The currents are smaller in both of them, so the power drawn out of them is going to be less compared to the ones in parallel. And that is all I have for you for this question, 2002 from AP Physics B. If you like and learn from my videos, go ahead and subscribe, and thank you for watching. See you in my next videos.